Okay, thank you. Yeah. Thanks for joining this talk. Actually, this talk is, our section is AI Infra. My talk is actually across the data and also the AI system part. Okay. Okay. Actually, this sentence I quote from Common Core. Yeah, you know the Common Core. Actually, that is the largest tax corpus, and they have established the Common Core data set for more than 15 years. And the mission for them is because they believe that everyone should have the opportunity to use their curiosity to analyze the world and pursue the great ideas. So they think everyone in the world should have the ability to do that. That's why they create this data set. Actually, let's imagine that 15 years ago, there's no large model. So when they do this kind of thing, they just want to enable the researchers to do the data-related scientists, okay? Okay, so for us to talk about the AI for good or AI open source for good, first I want to say the premise is we should enable AI to help us to make the humanity, society, and environment better. So this is the object. And under this object, we think we should build an inclusive AI. That means that ensure everyone can enjoy the benefit AI can bring to us. The second is very important. Is we want to lower the barrier for anyone to do the research for AI for good. So that every team in the world can have the opportunity to do the innovation and contribution for AI for good. So this is our idea about the AI for good and why open source is very important for AI for good. Lower the barrier for innovation. But today is really challenging, especially in current stage of AI with the large model. The first is for any of the large model innovation, especially for the innovation close to the foundation model, the cost will be really, really high cost. I know that today, this morning, have another parallel session talk about the model. And really, that kind of innovation is very high cost. So that's the first thing. The second thing is currently, if we want to do the research and development for the large model, we need a huge amount of data. And that kind of resource, we cannot get it from single organization. Or to say, today, any single organization without any open source of the data set, by themselves only, it's almost impossible for them to get all the required data set. Okay. The last one is, yes, today, till now, the computation resource is still very expensive, and for some of the team, even inaccessible. Okay, so these are the three very important challenges, and we want to see how we can leverage open source to build an ecosystem to help the global researcher and teams to solve these kinds of challenges. So this is us for BAAI. I think this morning's keynote opening, Daniel also mentioned BAAI. This is our mission and our goal. We are the non-profit neutral research established 6 years ago. And we dedicate to advancing any technology to help human well-being, champions the AI for good through, first one is to reduce the redundant cost of innovation. How we do that? We open source more than 100 large models. The idea is we want to contribute as much as possible. We open source all our trained model for the research purpose and commercial use purpose, so that we can help the whole world to reduce the redundancy of the innovation. Of course, we also benefit a lot of outside the open source model as well. The second is we open source high quality data sets, which will be free used by research and also by commercial. Anyone can download our release data set. So this is how we want to build these kinds of very important resource and share for innovation. And we also lower the hardware usage boundary. Later I will talk about that, how we build a unified open source stack so that we can enable the AI algorithm and AI model can run on different architecture, hardware architecture. And the last one is we also want to empower the most needed through AI. For example, we focus a lot of the accessibility of AI. For example, the elderly and also the children, these kinds of population. Okay. So today, let's go to the second one is data. I don't want to talk about the model because we have another entire introduction about the model. So I only want to talk about the data and compute. So these are the three very important data sets, very famous, and we cannot imagine if we don't have these three data sets, we might not get today's deep learning or large language model or multimodal model. Yeah. So these are very important open data sets. But for us, when we look at these important open source data sets, we found that, for example, our team, we come from China. We use a lot of Chinese. And actually these data sets, most of them, all of them, in the content of English. So we do need the high quality Chinese data set. And in the global, anyone, if they want to change the language model, the Chinese as the second large language, yeah, all the people will need this kind of data set. So that is our work in the past 3 years. We work together with a lot of different organizations to gather the Chinese data and do the process, filter the data, make it the quality good enough for the training, and also filter out those harmful data. Okay, so we already open source more than 100 different kinds of data sets. For example, some of the data sets have been downloaded by a lot of organizations, including the DeepSeek, including the global, a lot of big AI companies. One of our data sets it win the top 20 in the last year on PyDFX. You know, actually in last year, 2024, there are already 240,000 data sets open source on PyDFX. So we are happy that one of our data sets has been ranked as top 20. Okay. And this is just one example. We open source the text data set. We also open source the multimodal instruction data set. You know, the currently in those general multimodal model, usually when you download it, if you want to use it for some purpose, you need to do the post-training. And when you do the post-training, these kinds of instruction data set will be very important. And today, since the multimodal model is still under the innovation, so very lack of this multimodal instruction data set. So last year we open sourced this Infinity MM. It has thousands of, no, not thousands, 10 millions of the pair instruction, text and image, these kinds of pair instruction. This is a very huge data set. And you can also see the result. Here is the figure. These are in last year when we open source that, we also use it to post-train our based on one of the base model. You can see this the two VL model in last year, 2 billion. That's not a big model. And at that time, we use our model to do the post-training in the same size, and we got the SOTA result. So by releasing this data set together with this result, we just want to prove that this is really the high-quality data set. So that's why when we open source it, very soon have a lot of download, and we encourage people to try it on their model and also give us the feedback. And today, actually, we also will release this another very big data set. This is the Chinese corporate internet data set. it has become the 4.0, the fourth version today. In the past 2 years, we released the 1.0, 2.0, 3.0, and this year, we released the 4.0. This 4.0, this version, we have a very huge size, 35 terabyte for the storage, and in total, it is around the 6 tera tokens. 6 tera tokens, including the English and Chinese. We also will continue to publish the result. So very soon, maybe today or tomorrow, we will publish the technical report on archive to show how this data set can improve our language models training. And again, if you notice there's a parallel session to introduce the OpenSeq this morning. Actually, that OpenSeq model is trained with this data set. Or to say that we use that model to prove the quality of this data set and open source to the world. And we also very ensure the copyright issue so that we also filter out those data which we cannot open source. So when we open source that, you can look at the license, Apache 2.0, and you can feel free to use that. Okay, just now I introduced just the common or general data set. And we also will look at what will be the other important data set which will be very important needed by the industry. And let's see the children and elderly speech, okay? Today, actually, we found that for those children and elderly people means they more than 65 years old, okay? This population actually occupies 30% in China. 30% are children or the old person. And the situation for the speech recognition is compared with the normal, the people's WER, that is the error rate. The children and elderly error rate is much higher than our normal people's error rate. For our normal people, the error rate is 1 point something or 2 point something. But when we go to the children elderly, it will grow up to 20, 25 something, this kind of very high error rate for the speech recognition. But you can imagine that for the children, they don't know how to do the text, how to say the input. I mean the text input, okay? And for those older people, they also very, very rely on the speech. So these are the 2% of the people, they really need the speech capability, speech recognition capability of the model, but today's model is very bad on this stage. So that's the motivation why we open source the data set of these 2 kinds of population, from these 2 kinds of population, and because we want to encourage the global industry to improve the quality for them, okay. So this is the first Chinese conversational speech data set for senior talk. Senior talk means all the data collect from the people who is elder than 75 years old. Sorry, it's still the Chinese only, but it covers the different provinces, different areas in China. Okay, and also cover the male and female and cover the age from 75 to 85. And when we collect this data set, since we need to do the open source, so we also sign the agreement, get the agreement from each of them to, so each of them allow us to collect this data from them and publish it for the research and commercial purpose to train the smarter machine. Okay. The other one is
有一些菜，反正我喜欢吃红烧菜、炒菜。你像红烧肉。
In Chinese, just to let you know that actually it's not like us. We can say a sentence smoothly, but for those old person, they will say the sentence with a lot of different kinds of variants. Okay, so that's why today's recognition, we do need these kinds of special data set.
谢谢。
The other one is for children. This is the Tri Mandarin. It's still the Chinese conversational speech data set. It is for the young children. All the data collect between the 3 years old to 5 years old children. And the collection is with the parent guiding the dialogue. So actually it's not like, okay, I give the book to the children, let them to read it. Not like that. It is to ask the parents to do the conversation, normal conversation, daily conversation with the children. Because we know that today for our language model, we more have the usage like the conversation. So that's why we need these kinds of special scenario. Again, we also get the confirmation agreement from their parent, each children's parent, to allow us to open source this data set from their conversation and remove all the private information. So we currently did this set, so it's already the first one or the largest one in Chinese, but it only covers 600 people. We spent 6 months to collect that because we do need to sign the agreement from one by one to ensure how to do the open source in the legal way, and also we want to ensure the user of this data set feel safe when they use this data set. And this year we will continue to work with the university to deliver another larger data set. Okay. Okay, then after the talk about the data, then I want to move to the compute part. We all know that actually today, for NVIDIA, they have very strong ecosystem by using the CUDA. They built it for many years. But besides NVIDIA, in the whole global, we also have a lot of other innovation for a lot of different kinds of chipsets with different architecture. But we see that, especially for the AI domain, these chipsets actually their ecosystem, their system software is very fragmented. Their ecosystem is very vertical because they don't have their architecture is different, instruction different, compiler different, so that they need to build their own compiler. Even they have their own language, they will need to develop their own libraries. So this is very tough for the users because limited by each chip company's investment. Currently, not all the chipsets they have the comprehensive library support, and today also we can see the AI algorithm it moves very fast. So a lot of these kinds of hardware companies they cannot catch up this fast evolution for AI algorithm. So always we will see okay they lack of this kind or that kinds of libraries. Okay, and another issue is lack of compatibility between the AI chipset vendor. So that means once they run their algorithm or application on this AI chip and they want to migrate to another AI chip, that is need a lot of high R&D costs. So that's why today a lot of AI chips still cannot massively deploy in the industry. So that's why in the past 3 years, BAAI, we work together with a lot of companies in China and also some companies in global. We build this open source and unified system software for different AI chips. Actually, we sit just between the deep learning framework and the backend compiler. We sit here. This Flat OS currently include 4 keys, very in the core level. The first one is the multi-architecture compiler, the FlatChi. This is a unified compiler, AI compiler. And we also have built the general purpose AI operator libraries. We call it the FlatGems. We use the Triton language. I don't know if some of you heard about the Triton language. Yeah, we use the Triton language to build these libraries. And we also build a framework, the training and inference parallel framework, which can run on different architecture. And also we build a unified computation library. You know today, different AI chip, they have their own converged communication library. Okay, so these are the things we build together with the whole, a lot of companies, and we open source all the things. Okay, so we target to use this unified software stack to support the different AI chip, and on top of it, we can support the different deep learning framework. Currently, we support the PyTorch, and also this year we also will support the Python. And more important is we support different kinds of large model. And till now, we already support 17 chips from 10 global vendors. Actually, this stack also can run on NVIDIA. Okay. And very important here is, yes, this is really difficult to do that in the whole industry. I think in the past more than 5 years, a lot of different teams, they try to do this many times. But this time, we can get together a lot of different AI chip companies to work together, because we, at the beginning, we use the open source to do that. And today, we already get the support from the GPU architecture, DSA architecture, RISC-V AI. I know the next week there will be the RISC-V conference here in Paris. And yes, they extend the AI instruction, and currently our stack can run on RISC-V. And also we are running it, trying it on ARM as well. So here, you can see, let's go into a little bit more detail. First, I want to say that we can provide, by using this stack, FlatOS, it can provide you better performance on different hardware. So the first thing, let's compare with NVIDIA. Yes, as I mentioned, we use the Triton language to implement that. If you don't know what is Triton, in simple, it is the Python style program language, which can help you to easily to implement a library or operator for algorithm. So it's much easier than CUDA-C. Okay, it's open source first by OpenAI, and get a lot of adoption from Meta, NVIDIA, AMD, Intel, and others. Okay, but they don't have the library open source. So what we built in the past 2 years, we put a lot of effort by using the Triton language. We developed more than 170 most used operator libraries and open source them. And today, these Black Gems already become the largest Triton library for AI. And we also do the very careful testing already across different architecture and compare the result with CUDA, okay, to ensure the accuracy, okay. And let's see the performance. Here is actually our more than 100 operators performance. We have more than 76 of the operators have equal or even faster performance than CUDA. We test it on the same hardware, compare it even on the NVIDIA GPU. Here is another figure. That means that actually different color means different chipset. These are the other non-NVIDIA chipsets. You can see, compare with their original implementation, each company's original implementation, we can get average 2 times speed up compared with the proprietary implementation. And it's very easy for use. You can see that only one new Core 9, it can help you to enable this Triton library, Black Gems in your code by import and with this one line language. And we continue to work with the whole ecosystem to build more and more operators so that it can very fast to support today's new open source language model or multimodal model. The second is we also want to even further to provide a better performance, but automatically. So since you know that actually today the situation is we have different architecture of the model. We have the language model, multimodal model. We have the density model, and we also have the MOE model. Okay, different model. And we need to run this model, the training and inference on different cluster. It might be the 1,000 device cluster, or it might be the 10,000 device cluster. And if this cluster, they use different chipsets, so that you can see this is already the multi-dimensional challenge, very complex. So we don't want to purely rely on the humans experts to solve this optimization challenge. So that's why we developed the flat scale. This is the parallel framework for both the training and inference. It can automatically find the optimized strategy for the given model on the target hardware cluster and for the target device. Okay. So here let's see some result. Here we compare have the result on 7 billion, 34 billion, and 70 billion, different size of the model. And we try on the A800 is the NVIDIA's cluster, and the other one is other two different chipset cluster. And here is the speed up compared with the human's manual optimization. Okay, by using this flat scale auto optimization, we can get a better optimization result compared with the human's effort. So that means in simple is currently the model already very complex, hardware very complex, and also have different kinds of hardware, different kinds of model. We want to make the user easy. Just let them one click, then the framework can help to automatically get the best result for the user, so that they don't need to worry about how to do the optimization. Okay, this is another thing. Yeah, also the one things from our flat OS. Today we know that sometimes in our data center we might have only single type of chipset, but in the long run you might have multiple different kinds of chipset. You might have A100 or H100 from NVIDIA. You might also have the NVIDIA chipset plus other vendors' chipset. Okay, but one day you might think, if I want to train a larger model, can I use all these chipsets in the in my own data center to train to finish a single task? So this is how we say this is a kind of single model train on the mixed hardware. Okay. So we do need to do a lot of optimization in the data parallel, tensor parallel, pipeline parallel, different kinds of parallel, because if you mix for example, two kinds of chipset into one pool to do the training, we want to fully utilize the different clusters capability, but different clusters capability will be quite different, right? So that's why we need to optimize the parallelization strategy so that we can distribute the task and fully utilize the different chipsets advantage. And here, I don't want to spend the time on this part, but just to share you this result. This is the result actually we already done in the end of 2023. We are the first one open source this pool training, heterogeneous training work, and open source all the code. In our result here for this figure, 100, this line means that if you have the A cluster, you have the B cluster, you put them together to train a workload. 100 means that if you purely just use A, you can get the A capability, computation capability A. If you just use B cluster, then you will have the computation capability of B. Then the 100% means A plus B, okay? You don't have any loops, A plus B, okay? That's the 100%. But we found that by putting the A and B together for different configuration or different chipsets, sometimes we will exceed the 100%. That means you will have, sometimes you will get a 1 plus 1 larger than 2, okay? Why? We found that interesting is because when you have the opportunity to train in a larger cluster, then you even can enable some optimization method which cannot be done in a small cluster, okay? So that's the example. So you can see these kinds of results. And the other thing is we also need to ensure after this kinds of heterogeneous training, we want the model will have the same accuracy as we train purely on, for example, on NVIDIA. We need to ensure the model's performance. Okay, this is why we actually do this kinds of benchmark for the model after this kind of training, just to ensure this training is correct. Okay. And we also the flat OS will also help you to satisfy the different kinds of complication scenario. This tool is means that it not only can run on GPU or those ESA architecture, it can also be run easily on the RISC-V instruction, these kinds of new instructions, and also the reconfigurable chipset architecture, a kind of new architecture. And also here is in China, ARM China, they also designing the new NPU architecture. By using our stack, very soon, even when they do the hardware emulation, they can run this stack to ensure the hardware and software design is correct. And this one is another example that for the embodied AI today in the hardware, in the edge of the robot, people also want to run the large model in the robot. So very soon, we just use 2 days to enable our robot brain. This is an embodied large model run in the robot, can run on the edge side. Okay. And we also think, so the flat OS can help people to easily to do the migration from different hardware. Okay, but we even don't want the user to do the migration. How we do that? Actually, we also use our flat OS to migrate the open source model onto different hardware. So you can see, let's imagine that today in the CPU, you can download the MySQL, you can download the Apache, you can download different open source for different version of CPU, for the PPC version, for the ARM version, for the x86 version, right? You can download it directly on the website. So this is the same thing. You can see we have the DeepSeek, we have the